In the last video, we talked about points in R2, and in this video, we're going to talk about vectors in R2. So, a vector in calculus, we define a vector as having a magnitude and a direction. Every vector has a magnitude and a direction in calculus. In linear algebra, that's not necessarily true. So, in math 1C and D, which is the third and fourth quarter calculus, we often represent vectors as an arrow, or what some people might call a directed line segment. All right, so when we draw these arrows or directed line segments, we'll have what we call an initial point. We'll have what we call a terminal point, and then the vector is kind of a connectivity between these initial and terminal points. So perhaps you call this initial point P1, and we write it as an ordered pair x1, y1. You can tell this is a point because there's parentheses. Terminal point we'll call P2, and we'll write it as x2, comma, y2. So this is what we call the initial point. And you can tell it's the initial point because arrow starts here and points away. Or runs out of. This is what we call the terminal point. And the arrow points into this. Some people call this the tail and the head. So this could also be called the tail of the vector because it's the back part, and this is called the head of the vector. Right? And the direction goes along this direction. Okay. This vector you might call the vector x, and be very, very careful. We know this is a vector and not a coordinate because it has a vector hat. So this is what we call the directed line segment representation of a vector. So x is a vector connecting P1 to P2. So it connects those two. And we could write this, another way to write this is x is the vector that goes from P1 into P2. So notice the tail of this is P1, the head is P2, because the vector hat goes from P1 to P2. Okay. So a really interesting thing to note here is when we write a vector like this, to denote vectors, we use what we call angle brackets. Okay, so here x would be some x component and y component, and the x component is going to be the difference between the x coordinates of the points that it connects. So here if you looked at this difference, this would be x2 minus x1. That's the amount in the x direction that we go. And then this length right here would be the difference between y2 minus y1. So the x component of this vector is called x2 minus x1, and the y component of the vector is y2 minus y1, which is just the coordinates of the head minus the coordinates of the tail. Okay. So let's look at an example. To demonstrate this point, we'll draw the vector x, which goes from the point Q to the point P, where Q is 1, 1, and P is 5, 4. Well, we just saw how to draw those points in the last video. 1, 2, 3, 4, 5. 1, 2, 3, 4. And maybe we'll go one more for giggles. Hee, 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 hee. Okay, here we go. There's 1. And we go 1, 2, 3, that's 5 and 4. So here's the point Q. Here's the point P. We have the vector x, which is going to be the vector connecting those two. And it looks like x is going to go from Q to P. So this is the vector x. And we can calculate x as the first coordinate of P minus the first coordinate of Q. And then the second component of x is going to be the second coordinate here, which is going to be 4, 3. Okay. Notice that this vector actually has many different things. It has a initial point, a direction, and the direction is encoded here. The direction is to go 4 units over and 3 units up. And then if we have the initial point and the actual vector in this notation, we also have the terminal point. This is called an angle bracket. So this we call a left angle bracket. Notice it's distinct from a point. Points have parentheses, vectors have angle brackets, at least in this class. That's called a right angle bracket, and inside is a vector. So notice, the last thing I'm going to say is, warning. There are actually infinitely many vectors x that take the form 4, 3. So in particular, we could write another vector that starts at the origin. Here's the origin. Goes 1, 2, 3, 4 over, 1, 2, 3 up. So here's a vector x that actually, if I didn't tell you, you wouldn't know whether or not this vector was this one or that one. I mean, similarly, I could write yet a third vector, the exact same vector that starts at 1, goes 4 over and 3 up. Same exact vector. So, in other words, to specify a vector uniquely, we need to identify the components of the vector and either the head or the tail. If unwritten, if you are not specifically told, the tail or the head, you can assume the tail is the origin. 0, 0. All right. So a quick review of vectors. If you have a vector in R2, perhaps you call this thing x. And we'll say that x has two values. This is what we're going to call the first component. We do not call it a coordinate. Coordinates are reserved for points, components for vectors. So this is going to call the second component. And you could tell this is a vector because we use the angle brackets. Because I haven't specifically told you that this thing has a specific head or tail, you can assume that if I write the vector x is x, y, that means that the tail of this thing is the origin. Notice also that here we're using the symbol x as a vector, and you see a vector hat. Here the symbol x represents the number of units along the first axis that you move for the direction of x. All right. In the next video, we're going to start talking about how you can do operations on the set of vectors. I'll see you in the next video.